In this practice sheet, we are looking at limiting reactant math. So in the first problem, it kind of gives you a list of steps for how to go through the problem, which is helpful because these problems, the biggest issue students have is just knowing where to go next. And so if you can follow this long series of steps, these problems really aren't any more difficult than stoichiometry or ideal stoichiometry problems. It's just that there is a long list of steps, and so you kind of have to be able to problem solve and figure out where to go next. There are also multiple ways of solving a limiting reactant problem successfully, so we'll try and talk about some of those as we go through. But any problem, we first need to read through the problem and write a balanced equation if we're not already given one. So we'll start by doing that. Copper metal and silver nitrate react to produce copper 2 nitrate and silver metal via a single replacement reaction. So the first thing I'm going to do is write out the reaction. So copper metal, so that would just be Cu, and silver nitrate, so AgNO3, because I know both of those have a charge of 1. Ag is +1 and NO3 is -1. Reacts to produce, so I'll put my arrow, copper 2 nitrate, so I'm going to put kind of my ions, copper 2 nitrate is -1, so my formula would be Cu NO3 2, and silver metal, so that would just be Ag. And so now the next thing we need to do is balance this equation, because if we don't have a balanced equation, we can't do any stoichiometry. So I notice that there are 2 nitrates on the product side, so I'll go ahead and put a 2 in front of silver nitrate on the reactant side. And now I have 2 silvers on the reactant side, so I'll put a 2 in front of silver on the product side. And I think that makes everything in balance. So that's our first step, is to write that correct chemical equation and balance it. Next thing that we need to do is determine the theoretical yield of the product that we're being asked to find for both of the given values. And so if you look back at the problem, you might notice that it says that where it's asking us to find grams of silver that are produced from 100 grams of copper, so we have one reactant, with 200 grams of silver nitrate. So we have an amount of both reactants. So we need to figure out which one of those is going to be the limiting reactant. And to determine that, we need to figure out which amount is going to produce less product. And so you can convert and do the theoretical yield for both in grams, but what I like to do is start by finding it in moles. Then I can determine which one is the limiting reactant and then convert just that one into the final desired unit from the problem. But it's up to you. You can go all the way to grams the first time if you like, but I'm going to go into moles. So I'll start with both of these values. So 100 grams of copper, and I'm going to go grams of copper to moles of copper, and then moles of copper to moles of my target product, which is silver, moles of silver. And then I'll do the same thing for my 200 grams of silver nitrate of AgNO3. And the parentheses are not actually necessary for silver nitrate. Grams of AgNO3 to moles. And this just takes a whole lot of writing here. My hand tends to get sore, but the problem itself is really not super difficult. And I'm also going to convert this to moles of silver. So that way, once I have the moles of silver that are produced by both of my amounts of reactants, I'll be able to tell which of these reactants is my limiting reactant by the one that produces less. So let's go ahead and plug in some numbers. The mass of copper on the periodic table is 63.55 grams in 1 mole. And then for my mole-to-mole ratio, I will look at my problem. I see I have 1 mole of copper in my chemical equation, my balanced equation. There's no coefficient. And then I get 2 moles of silver out of that process. It's a 1-to-2 ratio. And then down at the bottom, I'll need to add up silver nitrate's molar mass. So a silver atom, which is 107.87, and you can kind of do this off to the side somewhere. 107.87 plus 14 for nitrogen, plus 3 O's, 16 times 3. So if we add all that together, I got approximately 169.87, so I'll round that to 169.9 grams in 1 mole. And then our mole to mole ratio, we'll come back to our equation. AgNO3, there's a 2 in front of that, so I'll put a 2 on the bottom of my conversion factor. And of course we already checked for silver, and it's 2 moles of silver. Okay, so now we just need to multiply these out. So 100 divided by 63.55 times 2. 100, let's do this in a calculator. 100 divided by 63.55 times 2. That gives me 3.147 moles of silver. And then on my other one, 200 divided by 169.9 times 2 divided by 2, which I don't really need to type in my calculator, so just that first part. 200 divided by, not times, but divided by 169.9 gives me 1.177 moles of silver. Okay, and so right away we can determine which one of these produced less product, and it is of course the silver nitrate that produced less product. And so this is our limiting reactant, the silver nitrate. So what I'm going to do is I'm going to go ahead and label both those things. So step 2 we kind of did. We determined the theoretical yield of the target product from both givens, and we're going to label the limiting reactant and the reactant available in excess. So the AgNO3 is my limiting reactant in this problem, and then the reactant available in excess would be the copper. There's going to be excess copper left over because we won't be able to use up all that copper because we run out of the silver nitrate. And so notice that even though I had 200 grams of silver nitrate and only 100 grams of copper, I still ran out of the silver nitrate long before I was able to run out of the copper, because not only is silver nitrate used at twice the rate of the copper, but also silver nitrate's molar mass is significantly higher than that of copper, and things react in mole ratios, not a gram to gram ratio. Okay, so we labeled our limiting reactant in our excess. The next thing that I'm going to do is I'm going to kind of put an X through this yield right here, because I know that I'm not going to be able to actually produce 3.147 moles of silver. And I'm going to take the theoretical yield from our limiting reactant, so our actual theoretical yield here, and I'm going to convert it into grams because the problem is asking me to find how many grams of silver, not how many moles of silver. So one more step here, moles of silver to grams of silver. And I know that 1 mole of silver, based on my periodic table, is 107.9 grams. So 1.177 times 107.9 gives me 127.0 grams of silver. And let's just check our significant figures here. But yes, I did already round that to 4, which matches what's in the problem, because all of our values here have 4 significant figures. Just out of interest, if you do have values with different numbers of significant figures in the problem, then your answer should have the same number of significant figures as the amount of your limiting reactant that you started with. So 200.0 has 4 sig figs, so our answer should also have 4 sig figs here. Alright, so this is our theoretical yield in the desired unit, so we'll label that. So we labeled this, we converted the theoretical yield to grams. Now we just need to figure out how much of the excess reactant was used up, and then we can calculate out how much still remains. reactants. So the easiest way I think to do this, and there's a lot of ways, is to take our moles, our theoretical yield in moles, and convert back to figure out how many grams of copper get used up with that number of moles. So that's what I'm going to do. You could also start with the amount of your limiting reactant. So you could start with 200 grams of silver nitrate and convert 2 grams of copper, but that's actually an additional step. So I'm going to start with the 1.177 moles of silver, and I'm going to convert it to an amount of copper that gets used up. And it should, what I get should be less than the 100 grams that were available, because we know that not all of this 100 grams is actually going to be used here. So here we go. We'll start with 1.177 moles of silver. And so we'll take our moles of silver to moles of copper. And then we'll take our moles of copper to grams of copper. And we really have all the information needed to fill in these conversion factors already available. So 2 moles of silver to 1 mole of copper, that's our mole-to-mole ratio. And then 1 mole of copper, we already said 1 mole of copper is equal to 63.55 grams of copper. So it's actually pretty easy to set up this dimensional analysis here. And so when we solve this problem, we end up with 37.4. And let's just double check that one more time. It's always good to check. It makes sense because it is less than 100. 1.177 divided by 2 times 63.55. So 37.399175 is my full answer, but I'm going to round that to just 4 significant figures, so 37.40, because when we look, this 9 is going to make it round up to a 10 here, which is then going to bounce over here and make that round up to a 4. So 37.40 grams of copper, and this is the amount of the copper that was used. So now we need to figure out how much remains. And so we'll just subtract that for the amount from the amount that was available. So we had 100 grams of copper available. 100 grams of copper that we had, and we'll subtract out the 37.40 grams of copper that we actually used. And I should be careful about significant figures here, because we actually had exactly 100.0 grams. And that does make a difference when we're subtracting, because remember, when we subtract, significant figures is actually having to do with decimal places. And so our answer here should have just 1 decimal place, not the 2 that are here, but just 1 decimal place to match the smaller number of decimal places. And so 100 minus 37.40 gives us a final answer of 62.60, which of course we are going to round to just 1 decimal place, so 62.6 grams of copper, and this is our excess, our amount of excess. So I'll label it as such, and we'll box in that excess. And then just to go back to make sure we've answered all of the things the question has asked us for, it said how many grams of silver will be produced, so that would be here. So I'm also going to box that answer in. So we're going to produce 120 grams of silver, 127, grams of silver. We'll box that in nicely. That's our theoretical yield. And then which reactant will be in excess and how much excess will remain? Well, we are going to have an excess of 62.6 grams of copper, and I labeled that as excess, so it is clear that that is the excess amount.